So welcome to the talk about getting started with embedded Qt development. My name is Johannes Zellner. I'm a customer services engineer here in the Munich office. I'm with Nokia since 1.5 years now. The mission from our team, customer service team in Munich, is to make Qt a success on non-Nokia devices. So what does that mean? Basically, we are helping customers to get Qt up and running on their target platforms and make sure that it performs best as possible on the devices and on their operating systems. Personally, I was recently involved in automotive projects like head unit creation and a project called Terminal Mode that helps the integration of Nokia phones within cars. So, if you take a look at the agenda, I'm starting with a small introduction. I'm actually talking about Qt for embedded devices. So, what different flavors of Qt we have and what is our offering for the embedded market there. The next step will be building your Qt environment for your devices. So, configuring the Qt libraries to fit the needs of your target, and also trying to get to manage the library sizes, for example, and do some fine-tuning there. And as the last step, I will have prepared a small application where I can show you how to cross-compile that and how you can use it with the previously built Qt environment and how to start it and test it. So the goal for this session is to enable you to configure and build Qt libraries on your own for your embedded device and create applications with those libraries then. If you have any questions in between, just raise your hand and I'll take that. So, Qt for embedded devices. Currently, Qt is already running on a lot of embedded devices. So, it's running on the coffee machine that you have in our demo booth there. We have set-top boxes Qt is running on. There are some navigation systems. And of course, mobile devices as Nokia phones. Those are also embedded devices. So yeah, Qt is running there. Most of those devices have kind of different operating systems. So as Qt is cross-platform, we have a lot of supported platforms there. We have the officially ones. Those are supported by us. In the embedded space, we have Linux, Linux embedded, whereas Migo is a special derivative of Linux there. We have Windows CE and Symbian. But on the other side, we have community supported platforms like Unix, VxWorks, or Integrity. Those are community ports. We have supported the porting there, but the main work was done by the community. And if your preferred operating system is not on the list, you can just grab the source code. And there was last DevDays a good talk about porting Qt to different operating systems from Harald Fernengel. It's available on the website. So just watch that video and start porting. And of course, we can support you there. So the first flavor that I'd like to introduce is Qt for embedded. Officially, it's called Qt for embedded Linux, but since it's running also on Unix, VxWorks, and Integrity, I prefer that term for that because it's not only Linux. Qt for embedded is a complete Qt port, so it comes with its own windowing system, the Qt windowing system, QWS. It's a client-server architecture-based system. It has very few dependencies, so basically it's just libc, pthreads, and some moth headers. So if you have your cross-compile environment set up, usually it builds out of the box. And it was designed for frame buffers. So for that, it usually requires direct hardware access. That's maybe some drawback. But it is really small, so even though it's client-server based, there is a possibility to have a single process run. So the first Qt application that is running on the device will act as the server for that, and all the other applications just connect as a client then. So single process mode is possible. That's very important on embedded devices if you have just limited resources. So take a look at the architecture overview. At the bottom, hardware and the operating system, and there directly sits Qt Core and QWS. So the windowing system sits on the operating system there and provides the functionality for GUI. On X11 or Windows, there sits the Windows or X11 API instead of QWS. So QWS has to provide the surfaces for the widgets and all the things that Qt GUI tries to draw into. QWS has also some special API. Those classes are not in the desktop-based Qt ports. So we have a QScreen class that is the abstraction of your display and your screen. We have a special QWS event that is actually a wrapper around the Q event class. We need a special event because we have, as you see below, QWS mouse handler and keyboard handler classes, for example, that enables you to create mouse or keyboard drivers for special input devices on embedded platforms, and those are producing QWS events. Those events then will be transferred to the QWS server application, and this again dispatches it to the currently focused application and pass it to the main loop of that application then.
Good morning.
Yeah.
One question about the mouse handler. I never have seen a mouse on a mobile phone.
Of course, the name is just mouse, but a touch screen is usually also a pointer input device. So yeah, maybe it should be renamed to QWS pointer handler, something like that. That's a good point, yeah. There are some other classes, but I don't want to focus in deep. There are classes for wrapping like drag and drop events. Since QWS is a full windowing system, it has also support for drag and drop clipboarding and window decorations, for example. So there are a few other classes also, but I'd like to focus on those, since those are important if you want to adopt QWS to your embedded device then. Since QWS tries to have less dependencies to the externals, we deliver free type library. It's packaged together with Qt there, and we have a special Qt font rendering system. It renders Qt pre-rendered fonts. Those are targeted for embedded because as they are pre-rendered, they don't use so much CPU to render it when they are used. The font handling is something special there. Usually on other Qt ports, we are relying on the X11, on the X11 font, or on Windows, on the Windows font system there. So as we have not those functionality on the QWS system, we provide the own font handling there. And something that is important here is that if you want to deploy the libraries and your application on the target, you have to make sure that the fonts are in some special directories. I will show you later on this. And Qt already comes with some fonts. They are bundled together with Qt, so some default fonts that are from free license that you can just freely use. As we have free type support, you can actually use any true type font that is needed. Yeah. So let's talk about the adaptation to your system. So as I said, we have the QScreen class that is an abstraction for display or screens. So QWS sits on top, and it relies on some special screen drivers. So we already have a lot of those, like we have a QScreen class for direct frame buffer, Linux frame buffer, and we have some special ones to Qt that are usually important during development process. That is a VNC output screen driver that acts actually as a VNC server. So that is important if you're in the development process and you only have your target device and there is not yet any display connected, but you'd like to deploy your application and want to see at least how the output will look like, how your application will look and feel. Then you can use that, and QWS will then act as a VNC server, and you can just connect with any other VNC library or client from your host computer. Of course, the performance will not be really good, but at least you can see already how the output looks like. And we have another Qt-only class there, or screen driver there. It's the virtual frame buffer. That is important during development if you don't even have your target device at the moment. So then you can build on your host machine a Qt for embedded build. Like I have it here, I will show you later on. And you compile the application with that Qt environment, and then you can start on your host computer a tool called Q Virtual Frame Buffer. And then you execute your applications on your host machine and display it in this tool. And I have an extra slide for this tool, and we will show it. Go through that when I'm starting to show you how the demo application works. Since I don't have any embedded device, I'll use that approach and this time. So in the middle you see a custom. So if you have your device and it doesn't have a Linux frame buffer or any other frame buffer device on your system, you have to write your own QScreen driver. That, in the easiest way, it will, for example, provide a pointer to some frame buffer, to some memory, and QWS then will hook up on that memory and draw into that. So that would be the easiest one, and it maybe has direct hardware access in this case. So it's fairly easy to do that, and we have already a few screen drivers in place, so you can use those as a reference. Just look at the source there. They are in the plugin subfolders in the source tree. Basically, if you want to have that, you just do a subclassing of QScreen, re-implement some methods like screen information methods in order to provide the available resolutions or the physical width and height of your display, to calculate the DPI correctly, and some information. And we have here the ability to make use of surface acceleration. But since QWS was designed for frame buffer, usually the acceleration of the surfaces is limited to some accelerating blitting. So you can re-implement methods like blit and use your hardware blitter to have accelerated surface splitting. Since the screen driver here just provides surfaces for Windows, this is not the acceleration of the paint engine. So this is not the place where you will add the acceleration for like OpenShell. That's just, in this case, you would just provide an OpenShell surface, and the acceleration will be done in the paint engine then. In order that Qt can find it on runtime, your screen driver, you need to implement a QScreen driver plugin. That is really a basic wrapper just around, it instantiates the QScreen instance and do some probing, and that's it basically. Providing some name information. So you can, as you see at the bottom, you can then use or exchange the output driver, the screen driver during runtime. So either you can set the environment passing in QW display and specify the driver. So let's say you have your target device there and you're not sure if your screen driver is working correctly or just the application puts some weird output on the screen. Then you easily just start the application with -display and the driver choose VNC and look at the connect from the host computer, and you will see what's the problem. Is it your screen driver or is it the application? So just on startup, define the driver you'd like to. And of course, you can pass in options like resolution, like bits per pixel, things like that, and display the configure the display number. That so you can, depends on your screen driver, you can maybe have multiple displays on the same device. Are there any questions on the screen driver adoptions? So the same or similar things as for input devices. It's just the event queue goes the other way around. So let's say you have a special knob that hasn't any Linux or QNX driver already in place. You can create your own, if you have a knob, maybe a keyboard input driver. Create that, listen on the hardware events within the driver. That is all done in the QWS keyboard handler class. You subclass that as you do with the QScreen, and provide a driver plugin with a name and the methods that Q can run to instantiate the hardware and set it up correctly. Really the same process for mouse and ECC touchscreen here. So this has only the capabilities of single pointer input. So there is no multi-touch in QWS currently. That's why it's just a mouse pointer in this case. As I said before, those two generate QWS events that will generate those events and pass it down to the QWS server, and it dispatches again to the current focused applications. Same as with the QScreen driver, you can choose on your environment when executing the application on the target, choose which driver you'd like to use. We already have default pointer input for Linux or QNX in place, but as you have your special input device or just hardware keys around your display, for example, you can specify the driver there and place in some options. Maybe during development you add some options like debug output level, things like that. So this was Qt for embedded. So that was a special port. Now we're going to Qt for X11. It's maybe confusing. Oh yeah. Question?
Just one question on QWS.
Yeah.
When I develop like high-level graphic applications with QGraphics View that should run both on embedded and on Windows, for example, yeah, do I really have to worry about the QWS layer?
No, not really. As long as you have a screen driver that supports some display output, you would be fine. Of course, on QWS, the acceleration is quite tricky at the moment, since it is designed for frame buffer devices. And that's, yeah. Oh, another question?
One question. The Qt embedded is, as far as I understand, Qt plus the QWS classes.
Yes, that's.
Is it a different distribution, or can I just download the QWS classes? Or
if you download the full Qt source, you will have it.
Okay.
Both.
Then I have
so
Qt
yes,
embedded as well.
Yes, we can later do that. It's what you get out of the source depends on how you configure Qt.
Ah, okay.
Yeah.
When I build Qt, I can choose.
Yes, that's true.
Because I was a little bit confused on the beginning. You said Qt embedded is running on MeGo, And yesterday I learned Migo is using X11.
Yes, so the embedded term is in this case confusing. But yeah, X11 is also chosen recently for embedded devices.
Okay.
That's why.
So do you plan to add multi-touch support to QWS?
No, I don't think so. No. QWS is not under heavy development currently, but you will see it later on what's there. So no multi-touch for now. Yeah, that's maybe also a reason for X11 in the future. I mentioned here X11 comes from the desktop space. It's designed for desktop, and it's a full windowing system. I mentioned it here because we had a lot of customers recently that are using X11 instead of QWS for various reasons, and the main reason is usually that it comes already with modern hardware acceleration, also on modern chipsets. And since embedded devices are gaining more power, they can run X11 out of the box, and if you have an open shell core in your graphics card, chances are good that X11 has already some acceleration in place. Whereas QWS was frame buffer oriented, so that's a little bit tricky. But QWS is like X11 is like QWS client server architecture, but a single process mode is not possible. So it needs an additional window manager and the server running. So you already have two processes running, and then comes your application. So at a minimum, you would have 3 processes running during startup already. And it's really complex due to a lot of extensions. So X11 was split up some years ago to a lot of small modules. This is good for desktop, but it makes the deployment really complex, and also the maintaining of X11 is hard there. It has a lot of external dependencies, so it's not really self-contained. But as I said, often hardware accelerated. And we will see it in the comparison here. X11 cannot run in single process mode, additional window manager, whereas QWS, the first application will act as the window manager. Yeah, a lot of dependencies. QWS is not, but modern graphics acceleration is really a drawback of QWS, and that's why we have started a project called Qt Lighthouse. That's not in 4.7 currently, it's under development. It will go in pretty sure in 4.8. It's actually it makes the adoption to windowing systems really easy. So if you have the modern windowing managers like from Kronos, the open code, for example, this is the way you'd like to go in the future, using Qt Lighthouse, because then you don't have to, like with QWS, your windowing system, and the other has also a windowing system, so there is a conflict, and then we don't have anything to offer at the moment. So that's why the project Lighthouse is started, and there is a good talk about that after lunch from Jürgen Lind. He's one of the minds behind Qt Lighthouse, and I guess he will also present some roadmaps, so you can think for future projects and based on that. So talk about your Qt environment. So first, in order to set up the Qt environment for your device, you need to do some preparation on your host computer, then configure Qt, do some fine-tuning for library sizes or which modules you'd like to have compiled into. Then I'll show you how to build those, and I'll give a short introduction to the host tool called QVFB that it's only available for Qt Embedded. So a central point during the preparation is choose a make spec. A make spec is that's a subfolder structure within the Qt source tree, and it's the base configuration files for Qt port. So we have a lot of those already in place. So if you start from scratch, just look into this folder. It's called makespec, the folder, and choose the one that is nearest to your setup, like Linux, ARM, G++, for example. Choose that, go into the folder and open the files. There are two configuration files usually, qmakeconf and qplatformdevs. And go into that, and there you can adjust things like cross-compiler environment, like where can Qt find the cross-compiler, where can Qt find the libraries, the header files from your target environment, and you can also specify compiler flags in there. That's an example one for Linux, G++. You will see some includes on top. Those are just the default definitions for the GNU compiler, for example, Linux, and QWS if you'd like to build a Qt for embedded build. And then you can override those in order to set up your toolchain. And maybe on the bottom, if you have OpenShell support there, you tell Qt where to find the libraries, or if you'd like to have some special free type library, that's the point where you have to specify those. So then you have your make specs, the basic configuration of Qt available. The next step would be to issue the configure script. That is configure script, as you know from all the other AutoTools projects. It has a lot of command line options. If you issue -help, you would see those. And there you specify also the flavor of Qt you'd like to build. In this case, with the -x platform, you specify the path to the make spec that you have chosen before and that you have modified before. And then -embedded says this will be a QWS build, and it's targeted on ARM processor. ARM here is relevant for atomic operations, for example, so Qt can choose the right paths there. And we have, especially for atomic operations and some paths that are performance critical, some assembly code, and here you can define which global architecture it has to use. The configure script, after issuing that, it will create qmake and does a lot of testing. And at the end, you will see an output like which modules are going to be built. Like it will, the modules that are going to build will depend on the tests that have succeeded. And all those tests are in config.tests. That's a subfolder. And if you have the configure command and you see, oh, I don't know, WebKit is not building, Qt WebKit, what's the issue there, or Qt OpenShell, and then you just go into the config.test subfolder and see, take a look at the small C++ example there and see why is the dependency check failing and what header files, for example, are needed for this one. And there's a convenient, the config.status, that's just a text file. And every time you issue configure, all the configure command line will get saved into this file. So if you come like some weeks later on to the project and see, oh, I need to add one more flag, just open the file and add the flag there and execute the config.status again. So now the global configuration of Qt is done, but especially for embedded devices, you need usually some fine-tuning. Because Qt libraries are really huge, there are a lot of convenience widgets and a lot of convenience classes in there. So you can fine-tune the library sizes there and also the modules. The configure script can take as a command line options like -no WebKit, so don't build WebKit, so no dependency checks will be done there and the module won't be built. Usually on embedded devices you know what modules and widgets you'd like to use, so you can also use the qconfig directly. The qconfig tool because the other options just disable some modules. Modules are all compiled in separate libraries, so you don't really gain much for if Qt GUI is too big. That's why we have qconfig tool, and there you have the user interface for that, and you really can select classes you'd like to have compiled into the library. Let's say you don't use the Q slider widget in your application, or you have just a graphics view application and you don't use any of the other convenience Qt widgets. You just disable those, and they won't get compiled into the library. There is a dependency check, so if you disable QLabel, like QWidget would be also disabled automatically. And there you can really strip down the sizes a lot. This makes startup performance much better then. The qconfig tool will generate the configuration file. We have some in the Qt source directory. There are some predefined, like a minimal configuration, maximum, and some intermediate ones. And you can start from those, save the file, and issue the configure command again with the -qconfig and pass the file to that. So then you will get a Qt configuration that fits the qconfig. Now, we configured Qt, so building is easy there. Just type in make. That's actually building here. And it will take some time. Maybe you'd like to pass some -J3 or I don't know, to have parallel compilation, grab a coffee, and yeah, it really takes some time, as you maybe already experienced on your own. I also mentioned here make install, because let's say you have a QWS build and you make, and then all the object files libraries are in your building folder, and now you'd like to know what are the files that need to be on the target, and what are the files that need to, like the header files that I need to build a project, and where are my host tools. So if you issue make install, it will install in the user local Trolltech and then the name of your Qt build, and there you get the whole libraries and header files that are used for deployment. So you have it there. You have also the host tools there in the bin folder, where you can create make files for your projects that have already all the cross-compiling environments set up. So do a make install and just search through the folder. It's not pretty huge, and use that for building your applications and not within the build tree. So that's it for building. Now you should have all the Qt environment set up on your host computer. So I don't go into detail about deployment because we don't have any supporting tools at the moment for deployment. So usually we do like setting up an NFS and copy the libraries over, or just set the install path to the path that is on the NFS share. And then you do some changes on the configuration or some widgets. You should again make install, and you will have those available on your new NFS. We won't have any tools for deployment of the Qt libraries itself in the future, but we will have in the next Creator release some general purpose deployment options within there. It's within the release 2.1 then. And that's for replication, not the libraries itself. Are there any questions on building or? No. Okay. So a pretty nice host tool for your host environment is the Q Virtual Frame Buffer. As you can see here, it's skinable. So you can have an image of your end product, and you can see how the application will look like with constrained screen sizes and how the colors will interact there. And you also have support for emulation of hard keys. Like you would see on the bottom, 3 keys there. You define those in the skin, and they will produce key event or mouse events, and they will get passed to the application that is currently running inside the virtual frame buffer. the virtual frame buffer is a host tool, so you will get this tool usually with your host Qt installation. So not with the one you previously built for your target, because it's a host tool. It needs like X11 on Linux or Windows APIs for displaying something on your host computer. That's why you have to have host Qt installation there available. In order to use it, pass -QVFB to the configure line, and you will get on your target Qt environment, you will get the screen driver for QVFB, and yeah, we can see it afterwards in the demo application. Yeah. Questions on building the Qt environment? Yeah.
One general question. I encounter when I build Qt, there's always, within Linux, you have 2 or 3 absolute links for qconfig.h. They are absolute links, so if you move Qt to another place after installing, the links are broken. So I always choose to convert these absolute links to relative links, so there is no problem. I don't see the point why you use absolute links.
Those are defined with the install prefix, usually. Yes. So you can pass to the configuration line, you pass an install prefix, and those will be the places there. So if you have on your target device, you'd like to have Qt in I don't know, opt Qt, for example, pass the prefix there, the install prefix, and the paths will be updated.
Yes, but it's only for free files. I think, as far as I remember, it's qconfig.h, and it is linked from source include, and these links are absolute links, not relative links, so you can't move it, or you have to be careful when you move it, because it points to another place. It's easy to convert them to relative links, but I don't see the point why you use absolute links there.
I don't know either, to be honest, in this case. Maybe after the talk you can point me out the files, and I can check why that's the case.
Okay.
Okay. So you have your Qt environment set up. So now let's create the demo application. I've prepared a simple one that is some frequency plotter. You may have seen it already in the QVFB screenshot. It consists of some backend that just creates random values, in this case a sine curve. And I choose to build 2 front ends. One is the widget-based front end, and one is a Qt Quick front end. Both are relying on the same backend and using the same data there. It's because on embedded devices, there are like embedded devices that need to have a fancy user interface, and they have hardware acceleration and everything. So there, Qt Quick is the right thing to choose usually. But if you have industrial devices, maybe you just need some basic widgets, some really stable classes, and you don't have any graphics acceleration. So just use the widgets there, and they will serve good job usually. So Qt widget frontend, it consists of a custom plot widget with some controls and a layout manager, and the backend is connected over the signal and slot. So nothing fancy, I guess. All of you already done something like this. It's just a normal Qt application, and so this is the main application. Pretty easy. Creating a main window, and the main window has some layout, creates a plot widget there, a push button for the controls as well as a slider. It connects to the backend for setting some values, add it to the layout, and instantiate the backend that produces the source. Maybe on an embedded device, it is connected to some sensor that is delivering some motion values, I don't know. whatever you'd like, and I start the backend. The backend usually looks like, it's also pretty simple in this case. It has a timer. It generates every 33 milliseconds a new value and emits the new value as a generated value. And see, I generate a new value over time with a sine curve. So that's it basically. Now I'm developing an application. So first of all, I select the project, and then I select the build I'd like to do. Usually, since hopefully my application is cross-platform, I select my desktop Qt version here. So there you select basically your QMake. So now I select the QMake of my desktop Linux Qt installation to rebuild. And then start application, and you will see it on my X11. You will see it's just this application with some controls, so nothing, just a Qt application. Now I see, okay, it works. Now let's test it for the target, and I have here a Qt for embedded build, for embedded Linux in this time. It's running on my desktop computer. I select again the QMake version for 7 embedded in this case. I'll rebuild it. In the meantime, I can check in the project settings of the startup the run arguments, and you will see here this is the runtime arguments for specifying QWS. So this application will act as the QWS server then, if you pass it down. If let's give it a try without that, and I run it, you will see the error message. It cannot connect to a local socket because it tries to connect to the QWS server. So passing the -QWS and start it again. So it's connected to a virtual frame buffer with some resolution, and the frame buffer is running on this desktop. And you see this is the tool. You have some, you can configure it, do some rotation, some scaling, whatever you like. And you have here within Qt for embedded Linux application running. And you see the window manager acting, and you can actually resize the windows and do whatever you'd like to. You can also close the application there. Usually on embedded devices, you would like to have like a full screen option there. But still, if you have dialogues in your application, you need something of a window manager to handle the focus properly. Any questions on this front-end demo application? Maybe I can show you without the creator, if you're more to the terminal. We're here in the widget demo folder. Now, if you'd like to build to cross-compile it, in this case for my desktop, if you'd like to cross-compile it, you need to have generated a special makefile. That can you generate with the host tool of your target Qt build. So I have installed it. Let's do a okay. I installed it also. So I have Qt embedded there. And within the bin folder, there are some host tools in there, like for mock and QMake, and the resources and translation things. So now I select this QMake here, and it will generate the makefile that uses the cross-compiling environment. So just make again, and now your application is built for your target. And you could run it there, same -QWS, and it's working again. So those are the only steps you need to know to build your to cross-compile your application with the previously set up Qt environment. Yeah.
In Creator, I've seen the very nifty checkboxes for my build targets when I create a new project, but I haven't found the option to add build targets later on when I already have my project.
So you have your project there. The project, sorry, my resolution is really broken. So in the build settings there, you can here choose the configurations. These are the one you have previously selected. Now there you can add new ones, and those are those that are known to the creator. You can make new ones known by adding those to the overall options in this window. So those are my 3. So as you see, this is the default one, Qt for 7 build.
I have one question about remote debugging via Qt Creator. Once I tested it, I think it wasn't fairly complete. So is there an option for remote debugging via Qt Creator?
Yes. In the current Creator, the focus was on Nokia phones. But with the next release, as I said, there will be some general purpose deployment options also, not just for mobile phones. And there the debugger is a lot improved, but it basically relies on remote GDB debugging. So you need to have the server on the target running. If you have that, currently it needs some strange configuration in the Creator in order to set it up, but the next release will help you there. So, take a quick look at the Qt Quick front end. So I just created something that can be in an instrument cluster maybe, and it just also displays the same values that are coming from the backend. The integration of the backend, since the backend is C++, I register it to the QML context and use property bindings to have it updated in the application then. So the application itself is everything within the main. I create the Q application, create some widget, place in some layout, and then add Q declarative view. Since I don't like to use the QML viewer because I have to register the backend, so I create my own QML viewer there. And as you see here, I pass in the source from a resource, so it can run out of the box on the target, and I don't need to have external dependencies. All my icons are also as resources in this case, and show it. There is of course you need the QML file. So the QML file, hopefully a lot of you are already attending some QML talks. I don't go into detail about this here, but you see that I have here a speed dial that is a QML item that some of us created. And here I do the property binding to the backend. And the data backend is known as the ID data backend in this case and has a property item that always takes the current value of the backend. So again, select the project, QML demo in this case. For 7 release, let's start it on the desktop, do some rebuilding. And voila, this is full screen now. I placed in some mouse area in order to control the backend. So if I press the mouse, you will see this goes like a little bit weird. It's a sine curve in this case. Okay, combined UIs. Of course, you can use both approaches if you have not so huge graphics card and you'd not like to have all your application within QML. You can just use both. Yeah. So at the end, some tips and tricks for running on the target. In order to test your graphic output, you can pass into every Qt application the command line option -graphic system, and then you can choose which graphic system the Qt Painter should use. Let's say you have OpenGL for your target, but the development is not yet finished and you're not sure if the application causes a weird output or it's the graphic system or the OpenGL backend. You can just switch it to like raster, for example. It's the best tested graphic system in Qt, and usually if it looks okay in raster, then it's the other graphic system has some issues. And also, as I said before, if you have your target device already available but no display output or the display driver is not yet finished, use the VNC to at least see how if the application works at all, like this. So coming to an end, we've gone through the different Qt flavors we have to offer for embedded. I mentioned only Qt for embedded and Qt for X11. And of course, we have Windows CE also. And in the future, we have Qt Lighthouse. So it's definitely worth to go to the Lighthouse talk after lunch from Jürgen Lind. And yeah, so you should be somehow able to decide which flavor you'd like to use and which flavor fits your target. Then you can configure Qt to your needs, like stripping down the library sizes, build Qt, and create application with the previously set up environment. So thanks for the attention, and
I have one more question.
Yeah.
I think you have solved the display issue quite well, but in embedded devices we have lots of other interfaces which are standards like CAN, I2C, SPIs. What do you do to support this directly with Qt?
Like if you have an input device that creates CAN data, for example, you have to take care in the QWS keyboard handler, for example, to directly access the hardware there and get the data out of the CAN for the knob, and then translate those to QWS events. You have done that also in the past, but you're restricted in QWS to the mouse and keyboard handlers for input devices. So input devices. So if you have some devices that are creating some other informations, we don't have any solution in place for this. So of course you always can create an object that reads the CAN and creates other QWS events or Qt events and pass that down to directly to the main loop. That's also possible. So if you do not like to be restricted to the input handlers, but then you have to do it on your own. But you can always pass in new events to the event loop, and the event loop will then take care, so the focused item will get the current events.
Hi, I have one here. I have one question.
Yeah.
You said that you can play a little bit with the library sizes.
Yeah.
So you can make them smaller by just rejecting stuff that you don't need.
Yes.
But did you ever try or consider let's say, think about updating the old Qt libraries, but using a binary diff. Did you ever play with that one? Or because, let's say, it's a remote site, it's very expensive to send a newly built library, but you want just to send, let's say, binary delta, because there are some binary diff algorithms. Have you ever tried it or played? Or
only module by module.
Okay.
Yeah. So.
Just coming back to the last question. So, what I don't understand, I mean, this is not the CAN interface is not related to a keyboard handler, whatever. It could be just a standard class, and what I'm looking for is an implementation that does that, so that not everybody using CAN has to do it on its own. So, do you know maybe there's a community effort to do some things if Nokia doesn't do it?
I'm not sure. I only know about virtual CAN, but. Yes.
Hi. You mentioned the pre-rendered fonts for QWS. Can I use them on Windows or on X11 too?
No, you don't get the font engine on Linux or Windows builds.
Okay.
Okay, thank you.